The National Electrical Code, or NEC, addresses the installation of dry-type transformers exceeding 112.5 kilovolt-amps, requiring them to be installed in a transformer room of fire-resistant construction. The code specifies that fire-resistant refers to a construction having a minimum fire rating of 1 IR unless otherwise specified. There is an exception which pertains to transformers with class 155 or higher insulation systems and separated from combustible material by a fire-resistant heat-insulating barrier. The code is referring to the system temperature that the transformer insulation is rated for, not the temperature rise. Insulation class indicates the maximum operating temperature that the insulation can withstand without degradation over its expected life. The system temperature is the maximum temperature the transformer is designed to operate at, and it considers both the ambient temperature and the temperature rise within the transformer. Temperature rise is the amount the transformer's temperature increases above the ambient temperature when it is operating at its rated load. The insulation class dictates the maximum allowable hotspot temperature within the transformer. The code focuses on the system temperature rating to ensure the transformer's safe operation and to mitigate fire hazards. If a transformer's insulation system is rated for a higher temperature, like class 155 or higher, and is properly separated from combustible materials, it can qualify for an exception to the fire-resistant room requirement. This is because the higher temperature rating indicates a greater ability to withstand heat without igniting nearby materials. To determine if a transformer meets the exception, it is important to verify the insulation class marked on the transformer's nameplate. This information is critical for confirming compliance with the NEC requirements and ensuring the transformer's safe installation. Transformers with lower insulation classes, such as class 105, class 130, or class 155, have low maximum operating temperatures. Transformers with higher insulation classes, such as class 180 or class 200, can operate at higher temperatures. The NEC provides guidelines for the installation of transformers covering aspects such as clearances, ventilation, and overcurrent protection. Following these guidelines is crucial to prevent overheating and potential fires. Proper ventilation ensures that the transformer can dissipate heat effectively, preventing the temperature from exceeding the insulation's rating. Overcurrent protection devices, such as circuit breakers or fuses, protect the transformer from overload conditions that could lead to excessive heat generation. When installing a transformer, ensure that it has adequate clearance from walls and other equipment to allow for proper airflow. The transformer's nameplate provides important information about its voltage rating, kilovolt-ampere rating, and insulation class. This information is essential for selecting the correct overcurrent protection and for verifying compliance with the NEC. For example, if a transformer has a class 155 insulation system, it can operate at a higher temperature than a transformer with a class 105 insulation system. If the transformer is installed in an area with a high ambient temperature, it is important to choose a transformer with a higher insulation class. Also, the fire-resistant heat-insulating barrier needs to be properly installed to meet the exception. The purpose of the barrier is to prevent heat from the transformer from reaching combustible materials. The barrier should be made of a material that is non-combustible and has a low thermal conductivity. Some examples of materials that can be used for the barrier include concrete, brick, and mineral wool. When installing the barrier, it is important to ensure that there are no gaps or openings that could allow heat to escape. The barrier should also be properly supported to prevent it from collapsing. If the barrier is not properly installed, it will not be effective in preventing a fire. When selecting a transformer for a particular application, it is important to consider the system temperature rating and the insulation class. If the transformer will be installed in an area with a high ambient temperature, it is important to choose a transformer with a higher insulation class. It is also important to ensure that the transformer has adequate ventilation to prevent overheating. In addition to the NEC requirements, some local jurisdictions may have additional requirements for the installation of transformers. It is important to check with the local authorities to ensure that the installation complies with all applicable regulations. Consider a scenario where a 150 kV dry-type transformer with a class 155 insulation system is being installed in a building. The building owner wants to avoid constructing a dedicated fire-resistant transformer room. Firstly, verify the transformer's nameplate to confirm the class 155 insulation rating. Secondly, determine the ambient temperature of the installation location. If the ambient temperature is relatively low and the transformer is adequately ventilated, it may be possible to utilize exception No. 1. One must ensure that the transformer is separated from any combustible materials by a fire-resistant heat-insulating barrier. The barrier must be constructed of materials with a 1 fire rating, such as gypsum board or concrete. The barrier should extend beyond the transformer's footprint to effectively contain any potential heat or flame. The barrier should be installed in accordance with the manufacturer's instructions and any applicable building codes. It is important to consult with a qualified electrical engineer or inspector to ensure that the installation meets all applicable requirements. The exception requires that the transformer be separated from combustible materials. Combustible materials include anything that can easily catch fire, such as wood, paper, and cloth. If there are any combustible materials near the transformer, they must be removed or protected by a fire-resistant barrier. If the transformer is installed in a location where there is a risk of fire, it is important to have a fire suppression system in place. The fire suppression system should be designed to quickly extinguish any fire that may occur. Fire suppression systems can include sprinklers, fire extinguishers, and fire alarms. These systems can help to protect the building and its occupants in the event of a fire. Regular inspections and maintenance of the transformer are essential to ensure its safe operation. Inspect the transformer for any signs of damage, such as cracks, leaks, or corrosion. Check the connections to ensure that they are tight and secure. Clean the transformer regularly to remove any dust or debris that may have accumulated. It is important to keep the transformer clean and well maintained to prevent overheating and other problems. If any problems are found during the inspection, they should be repaired immediately. Delaying repairs can lead to more serious problems and potentially create a fire hazard. By following these guidelines, one can ensure the safe and compliant installation of dry-type transformers, minimizing the risk of fire and protecting property and lives. Remember to consult with qualified professionals and adhere to all applicable codes and regulations. When dealing with electrical equipment, safety should always be the top priority. The National Electrical Code, or NEC, Section 450.21, B provides the specific requirements for dry-type transformers installed indoors. It states that individual dry-type transformers of more than 112.5 kilovolt-ampere rating shall be installed in a transformer room of fire-resistant construction. Unless specified otherwise in this article, the term fire-resistant means a construction having a minimum fire rating of 1 Exception No. 1 allows for an alternative installation method for transformers with class 155 or higher insulation systems. These transformers can be separated from combustible material by a fire-resistant heat-insulating barrier. The barrier must be sufficient to prevent the spread of fire and heat to combustible materials. The code also requires that transformers be installed with adequate ventilation. Adequate ventilation is necessary to prevent the transformer from overheating. The amount of ventilation required depends on the size and type of transformer. Consult the manufacturer's instructions for specific ventilation requirements. The code also requires that transformers be protected from overcurrent. Overcurrent protection devices, such as circuit breakers or fuses, must be sized to protect the transformer from overload conditions. The overcurrent protection device should be sized according to the transformer's nameplate rating. It's important to understand the difference between temperature rise and system temperature when selecting and installing transformers. Temperature rise is the amount that the transformer's temperature increases above the ambient temperature when it is operating at its rated load. System temperature is the maximum temperature that the transformer is designed to operate at, taking into account both the ambient temperature and the temperature rise. The insulation class of the transformer determines the maximum allowable system temperature. Therefore, the NEC focuses on the system temperature rating to ensure the transformer's safe operation and to mitigate fire hazards. The code requirements are designed to protect people and property from the hazards associated with electrical equipment. It is important to follow the code requirements carefully when installing and maintaining transformers. Proper installation and maintenance of transformers can help to prevent fires, electric shocks, and other hazards. In addition to the NEC requirements, some local jurisdictions may have additional requirements for the installation of transformers. Be sure to check with the local authorities to ensure that the installation complies with all applicable regulations. Always prioritize safety when working with electrical equipment. If one is not qualified to work on electrical equipment, it is important to hire a qualified electrician. Working with electrical equipment can be dangerous, and it is important to take all necessary precautions to prevent injury or death. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The NEC is available for purchase from the National Fire Protection Association (NFPA). One can also find information about the NEC on the NFPA website. Staying informed about the NEC can help one to ensure that electrical installations are safe and compliant. Always consult with a qualified electrical engineer or inspector for specific guidance on transformer installations. They can help to ensure that the installation meets all applicable codes and regulations. This is especially important when dealing with complex installations or when there are any questions about the code requirements. The NEC provides a comprehensive set of guidelines for the safe installation and operation of electrical equipment. By following these guidelines, one can help to protect people and property from the hazards associated with electricity. Remember to prioritize safety and consult with qualified professionals when working with electrical equipment. When examining transformer specifications, pay close attention to the insulation class and temperature rise information provided by the manufacturer. This data is critical for ensuring the transformer operates within safe temperature limits. The system temperature represents the sum of the ambient temperature and the temperature rise. If the system temperature exceeds the insulation class rating, the transformer's lifespan can be significantly reduced. Regular monitoring of the transformer's operating temperature can help to identify potential problems before they lead to failures or fire hazards. Infrared thermometers can be used to measure the surface temperature of the transformer while it is in operation. The NEC provides detailed guidance on the selection and installation of overcurrent protection devices for transformers. The overcurrent protection should be sized to protect the transformer from both overload and short-circuit conditions. The size of the overcurrent protection device is typically based on the transformer's kilovolt-ampere rating and voltage. Always refer to the NEC tables and calculations for accurate sizing of overcurrent protection. Proper grounding of the transformer is essential for safety and to prevent electrical shocks. The grounding system should be designed to provide a low impedance path for fault currents to return to the source. This helps to quickly trip the overcurrent protection device and de-energize the circuit in the event of a fault. The NEC provides detailed requirements for grounding electrical systems. The use of properly rated and installed surge protection devices can help to protect the transformer from voltage surges caused by lightning strikes or other events. Surge protection devices should be installed at the transformer's primary and secondary connections. The surge protection devices should be sized to handle the expected surge current. Regular inspections of the transformer's enclosure can help to identify any signs of damage or corrosion. Any damaged or corroded component should be replaced immediately. The enclosure should be kept clean and free of debris to ensure proper ventilation. The NEC requires that transformers be installed in a location that is accessible for inspection and maintenance. The location should be well lit and provide adequate working space. The location should also be protected from physical damage and environmental hazards. Keeping accurate records of transformer installations, inspections, and maintenance activities is essential for ensuring long-term reliability and safety. The record should include the transformer's nameplate information, installation date, inspection dates, maintenance activities, and any repairs that have been performed. These records can be helpful for troubleshooting problems and for planning future maintenance activities. In summary, understanding the NEC requirements for transformer installations, paying close attention to temperature ratings and insulation classes, and implementing proper maintenance practices are all essential for ensuring the safe and reliable operation of transformers.